Okay, we're still in Math 120 and we're doing Project E. Again, I want to remind you to launch Sage. What you're going to do is, it may be in your doc. What are you going to click on? Sage Math 9.4, if that's the version you're running. If you're not running 9.4, like if you have a newer version or old version, you're going to launch Sage. Again, there's two ways to run Sage. One is through a command line, which is my preference. And the other preference a lot of people have is with Jupyter Notebooks. The advantage of a Jupyter Notebook is that you're actually going to have a chance to save the file as a document that could be shared. All right, and that's really nice to have. As when I'm doing things on the command line, basically it's just a kind of a dirty way to program it. I do it at command line, but I'm not really saving the file. I'm just working on it, and that's why I like to do that. It's almost like having a handout calculator. This is why I like the command line. It's like having a handout calculator. Whereas if I'm in a Jupyter Notebook, it's something I may be interested in saving my work. All right, but I like to run it from a terminal. Let me open it up. I notice I have a prior session of Sage open. I'm going to exit out of that. That's EXIT. And then I'm going to close the window to get rid of it. All right, so I'm back to Sage. And what I want to do is, I want to go back and talk about the project. And the project over here, it's a Sage project content, and it's related to the Math 120 material that you were taught. Now in Math 120, you're certainly taught trigonometry, but then they go through what's called a conic section, and they go through rotations of conic section. It's related to trigonometry. So the bottom line is what they want you to do is realize, they want you to graph this guy over here. And I'll be honest with you, this is a question directly taken from the notes, the Math 120. It's a rotated conic section. It's an ellipse, by the way. And the bottom line is it's rotated. Once we kind of remove this, difficult part of it, which is the minus 6 root 3 xy, by making a substitution, we come up with a pretty simple statement over here, which is basically just an ellipse, right? Really easy to graph that. Really easy to graph it, by the way. By the way, the numbers may not be nice, but easy to graph it. But what we're going to do is point out that I always find it very tedious to eliminate the xy in the problem. It's a lot of work, and if the numbers aren't nice, it's backbreaking. And machines can help us in the backbreaking work, and that's what we want to talk about, is kind of using a computer algebra system to help us out with this. All right, so what I want to do is I'm going to go to computer algebra system. I'm going to go to my terminal. I'm going to reset. And again, I'm looking at my code. The code is behind me. And I'm going to define a variable x and y. So x and y are variables. I define them before I use them. So x is a variable and y is a variable. And this should be very familiar to you at this point. And what am I going to do? We're not going to do something a little bit different. And what I'm going to do is I'm going to write down equation EQ1. I'm going to assign it. This is not a variable, it's a placeholder now. And what do I want to do? I want to store this equation over here, which is 13 star x squared minus 6 star square root of 3, okay, star x star y plus 7 star y squared minus 80. Now remember, an equation is indicated by two equal signs. And if I make a mistake, it'll say I made a mistake. It looks like I didn't make a mistake. What I'm going to do is I'm going to display equation 1 for you, show you what it looks like. And it looks like this. And so it says, well, they reordered it. Yeah, maybe, but it's not a big deal for me. I see the minus 6 square root of 3xy. Yeah, I see that. 13x squared, I see that. Plus 7y squared, I see that. Minus 80 is equal to 0. That looks pretty good. I'm going to type in the other equation, call it equation 2 now, EQ2. The equal sign is an assignment operator, and that is x squared, all right, divided by 20, plus y squared, divided by 5, and that is going to be an equation that's equal to 1. I'm going to display that, see how I did, EQ2, and what do I see? Yeah, again, it might look strange to you, but it's really x squared divided by 20, it's 1/20 of an x squared. 1/5 of a y squared, or y squared divided by 5, is equal to 1. Looks pretty good, all right? Now, granted, again, looking back over this, they didn't do that. They simply typed it in. What I want to do, though, is I'm gonna have other placeholders of graphing these guys over here. So I'm going to say IP1. This means image of plot 1, and I'm going to assign that implicit plot, and that's going to be an implicit plot of equation 1, EQ1. And I'm going to say the x's are between -6, sorry about that, and 6. And I want the y's to be between, I want the y's to be between -6 and 6 as well. Again, if I make a mistake, you'll say I made a mistake. Now, if I want to show that graph, let me do that for you. I'm going to do IP1.show. And you're going to see what happens. It's going to show that picture. And I see that. Now, what does that look like to me? An ellipse that's been rotated. I'm going to close that out. And I want to make another implicit plot. I'm going to call it IP2 equals implicit. I know I say it's a lot, but if you make a mistake, you make a mistake. It's not going to end the world for you. EQ2. And you know what? I'm going to do a copy paste. If I want to show that, I'm going to do IP2.show. And that's going to be an equation of ellipse. All right, I got that. All right, let me close it out. Now what I want to do is I want to take both of those graphs and plot them together. Oh, you know what? They got a third graph over here. What do they have over here? Let me see what they have down here. I got to look at that. IP1, IP3, implicit plot. IP1, implicit plot. We got that one down. And IP2. Oh, you know what? I'm sorry. I should have spoke about this when I'm here. This is actually the rotation, line of rotation, which is 60 degree, a line that goes through at 60 degrees. I'm going to put that down now. Sorry about that. IP3 is equal to an implicit plot. And again, this is a line of rotation, by the way. Implicit plot. And that implicit plot, square root of 3, SQRT. 3 star x is equal to y. That's a line that goes through the origin at a slope of 60 degrees, by the way. And then I think I had the same range in that guy over there in domain. Yep. Let me show that for you, show you. Show. Whoops, I'm sorry about that. IP3 dot show. And you're going to see a line that goes through the origin. Someone says, I don't see the origin. 0, 0. It's right over here. And it's a line that goes through the origin 60 degrees. All right. So again, I want to claim over here, you know, this over here, I'm going to copy paste it. This is show, and they're going to add all 3 graphs together. And you get this over here. What are you seeing? You're seeing the line of rotation. That's a line, by the way. And you're seeing the ellipse that's not rotated, and you're seeing the ellipse that is rotated. They should look identical to you. All right, what I'm going to claim over here is that I do like Sage. I think it's a great product, and there's many ways to customize the graph. But look at this graph over here, though. And what I mean by that is, whoops, I went a little bit too far in that, didn't I? That this is a really nice-looking graph. When you compare it to what I just did with Sage, which took me some time to put in, by the way. So let me go back to that. If you look at the Sage graph, they're really identical graphs, but the graph in my notes looks so much better. I mean, it really does. I'm not saying the Sage graph is bad, by the way, but the graph in those looks so much better. And the reason for that is I actually find some applications easier to use than others. And the application I'm using over here, I want to go through that with you. I'm using an application called Grapher. Right? Grapher is much easier to use than Sage. But again, I want to point out, Sage can do this too. It can color graphs, it can do dotted lines, it can put the axes in, but it takes a lot more work to do it, right? A commercial application, all right? But anyway, here's the deal. I'm not telling you that any one piece of software is going to be your saving grace. I would say the more tools you have at your disposal, the better it is for you, all right? The better it is for you. We'll get the project up later, by the way. But what's this deal about? You know, in Math 120, you did rotation of conics. It's a lot of work. Machines can help us out with that, all right? It really can, all right? Thank you so much for paying attention. I do appreciate it.